Yes. Yes.
It's like the slides by them to be presented there.
So you want to use Google Slides?
Yeah.
Yes, that's right. Send me. Good morning, everyone. Welcome to the Travelers presentations. Allow me to invite Ms. Michelle England. She's from Travelers and she's going to be adjudicating your presentations. So thank you so much, Michelle, for coming. She's been coming for years and we are extremely grateful to have her. All right, today we'll have senior presentations. The roster, you should have a roster to have the order. Up first, we'll have Yi Cheng and Shen Yi. And they're gonna talk about their project on portable device to assist cell checking process. Thank you. All right. Looks like you need to sign in. All right. Look at that. All right, why don't you hold up for two minutes? Let's start at page 15, shall we? Yes, we can. We're waiting for your faculty advisor to come. Yeah, yes, I mean, it's just fair, it's just fair. But very. You want to use this? No, like I just, I'm killing it, right? I see. So this is where you go. This is, yeah, this one. Oh, no, I mean, right. You wanna drive? Okay. Because it's the hours. Oh, this one, I see. So which one is this? This one, okay. So this way. Go on, test that. Do you wanna? Go on, test that. I see, I see, exactly. So you wanna try? Sure. Is a video working? You might have to request access. That's what, as I'm sure. If we can. So you know what to do. Maybe one more drag yours. Yeah, one more minute then. Put you. Yes, I understand.
You can go ahead. Good morning, everyone. We are the portable device to assist shelf checking in libraries group. I'm Xinyi, and this is my partner Yichen. We came to this idea and made this device because Yichen worked at the Trinity Library for about 2 years, and it has always been a problem for the library workers to work effectively, manage their collections. As we all have into our library, which has a huge collection of books, to ensure books availability and accuracy, the library staff take on responsibility of regular shelf checking, which involves staffs going into shelves and making sure every book are in their correct place. Current method requires student staff take their laptop with an open spreadsheet. They go over the bookshelves and say if the book order matches the order suggested on the spreadsheet. It requires them to go over each shelf twice, one for checking and another for reordering. The whole process takes a lot of time and effort. So we built this small device. It can provide clear instructions to users. Users can check books and reshelf them at the same time. With the assist of our device, each individuals who have never done shelf checking before can finish the whole process alone. So our method only needs to bring 3 things to the shelf: the device, a portable charger, and a barcode scanner. Each book has a label with a combination of letters and numbers on its spine. These numbers are known as the call number. The Trinity Library uses it to organize the books. This is the first page of our device and shows the information of current book, which should be the leftmost book on the shelf. Notice that the books are ordered from left to right based on the call number. The first line is the book title, and the second line is the call number of the book. We emphasize this call number because it is the easiest way to locate books on the shelf. Here is a quick demo of shelf checking with our device. The call number on the book bridge is the same as the call number on the screen, which means the book exists and is in the right place on the shelf. So click book found button and the screen will go to the second book. Then the call number on the book and the screen matches. So click on book found and the screen will go to the next book. When both call number matches, the user only need to keep going right and click on book found. However, books are not always in their right place. Sometimes stranger books are found. Sometimes books are misplaced.
So apparently sometimes the books are strangers, because you can see this is an obvious one, like a B book appears in between the PR books, which is not supposed to be in there. So that's where the barcode scanner would use. So there is a place to scan in the barcode. So the whole principle is like if the call number doesn't match, you scan the barcode and it will tell you what to do. In this case, it is telling you to move the book and return it back to the help desk in order to reshelf it, because it is not supposed to be there. Also, there are cases that the book is misplaced. For example, this grade book should be in the end of the shelf, but appears in the front. In that case, and also you should all so its place will be like taken by other books, right? So you will be needing to scanning this book's barcode again, and well, at that moment, nothing will happen, but like after n books, after the first misplaced book appears, there will trigger like a reordering loop, which will tell you like which will generate all the instructions you need, and you will follow instructions. It is easy to follow, and like go say that like move this book from the shelf. And you keep going, and whenever you reach the correct position of this gray book, it will tell you again like to this next book needs to be reshelved to the current position, so that you're doing the reshelving at the same time when you're checking. That saves like the half of the time doing the shelf checking and the logging. Okay. So the whole software structure is like that. We have like we show the like the book checking, and those are the two we didn't show. We have a logging page which takes in the student ID, which you can make logs, keep track of like how much time a student take to for each task and how many times they did a task and other things. And the second page is task UI, which reads the file. This is a spreadsheet that will be pulled by the data from the database of the libraries, and a book list and a book dictionary will be generated. And this is the structure of how the shelf checking process we show. So apparently it has like a keep tracks of current book and a local list, and if it encounters some stranger book, it will set a flag and create a temporary list. After the n times a compare loop will appear, and and within the compare loop is like a editing distance problem is lying over there. So that's what. We've tried like this user, we've let our users, like workers from library, try this device, and they give us like an average of 9 out of 10 grade. Several feedbacks they made: it is easy to carry, it is efficient, and only see like they only see one piece of data instead of like reading the whole spreadsheet. Also, some of the bad thing, downside of this is like still there are 3 things to carry. If we can integrate the battery into the device, there'll be only 2 pieces. And overall, over more than 70% of our users are willing to use this for the shelf checking process. And this concludes our presentation, and we're happy to accept any questions you may have. Thank you.
Thank you, Chen and Shelly. Any questions for our presenters?
How are you kind of how is that book list kept up to date? Because I know obviously there's new books coming into the library and there's books being removed and archived and things like that. So how is that happening?
Yes. So our device only keep tracks of like take care of the part that go back to this page where the task 1, so usually like this list is pulled before you go to the shelf check, pulled from the database, and that is where it gets updated. This thing has no direct connection to the database. However, because this semester is this year, we found out like a kind of tricky to work with the Xlibris Elma database. We have access to, we tried still it is kind of like it didn't work out, so we changed our switch gear to this one.
So you're kind of downloading what you need.
Download. Yes, exactly.
Okay. Thank you.
Thank you for the question.
No more questions? Thank you so much. You can be back. Up next is Dheeraj Anandaji. He's going to talk about his project regarding data generation for cybersecurity.
Good morning, everybody. Today I'd like to introduce my senior project titled Data Generation for Cybersecurity Applications. So I'd like to start off by motivating the problem a little. So cyber attacks. Cyber attacks are basically assaults launched by cyber criminals on computers or networks. They cause about $6 trillion in damages around the world annually, and that number is projected to increase to 10.5 trillion by 2025. So we can, as we can see, this is a grave problem. I have some example cyber attacks listed down. One example of a cyber attack is a port scan, which is something attackers do to check for available ports to attack. Another attack is DDoS, a distributed denial of service attack, which you might have heard of, which focuses on expanding a server's network resources and keeping it down. Web application attacks, which are getting more popular as web applications get more popular, phishing and malware, and etc. And most communications happen over the internet, which is a very public place and filled with vulnerabilities. And the need of the hour is to detect these attacks before they happen, because they're very grave and we need to be able to stop them before they happen. So one possible way to detect these attacks before they happen is intrusion detection systems, which is a system that a lot of organizational networks have behind their firewalls. So this is a diagram of a typical organizational network structure. As you can see, the IDS is usually behind the firewall. So what is an IDS? Basically, it's a system that detects malicious traffic. Traffic comes in from outside sources. And the intrusion detection system kind of judges whether the traffic is benign, regular traffic, or attack traffic. So there's two types of intrusion detection systems: signature and anomaly-based. We'll be looking at anomaly-based in this project. So anomaly-based detection, IDSs usually work on machine learning methods. So basically, a lot of data, machine learning models are trained on a lot of attack and regular network traffic data. And the ML model, it can learn to detect when an attack happens and when some given traffic is just regular benign traffic. So now, the problem with this is you have to train the machine learning models for the IDSs on some cybersecurity data sets. And there's two main problems with cybersecurity data sets nowadays. The first problem is that there's privacy issues with them. So the data for these cybersecurity data sets that the IDSs are trained on is collected from users. So inevitably, there's a lot of possibilities of the data containing personally identifying information about users of a certain network service. And another problem with cybersecurity data sets, especially in ones which talk about cyber attacks, is over and under representation of data, or in another way, class imbalance. We'll see this in the data set I'm work within this project too. But basically, certain classes in the data set are overrepresented, as in they have a lot of data points compared to other classes which don't have as many, which makes the ML training process for IDSs worse, because we don't have enough data to train with for specific labels. So to solve this problem, my project's goal is to generate synthetic tabular data using generative adversarial networks, or GANs. By generating synthetic data that is very close to the original, but not quite the original, we bypass the privacy problem, as we still have the same trends, the same type of information as the original data set, but we bypass the privacy problem because it's not actual user data. It just looks like it. And the class imbalance issue that I talked about, where some labels can be over or underrepresented, is solved by training the GANs on the sub data sets where the classes are under or overrepresented, and generating more points than they're in the original data set to facilitate better training of future IDS ML models. So our novel approach here is to use feature selection, which is something I'll talk about, to select the best possible features from the data set, and label separation, like I said, to reduce class imbalances. So the data set I worked with is the intrusion detection data set from the Canadian Institute of Cybersecurity. Quick rundown: it has 14 different types of attacks and 77 features. So when you look at a data set, your features are basically like your columns. And these are the types of attacks, like the labels in the data set. As we can see, the data set I worked with was also extremely, had a lot of class imbalance problems. DDoS, for example, had 350,000 data points, and Heartbleed, for example, which is an attack, had only 15 data points. So my project helps to resolve this class imbalance problem as well. So yeah, problems with the data set, extremely large, class imbalance, which causes complexity of model and 77 features, which we need to rectify. So quick walk through my approach. The data is pre-processed, and then the best features are selected, and then the data set is split based on the label on the different types of attacks, and individual GAN model is trained on each, and then statistical similarity is calculated. I will now go through the into more detail on each of the modules. So let's start off with data pre-processing. Very quick step. Just cleaning the data to make sure that it is usable by ML and GAN models. Basically like converting strings to numeric types, manually removing infinite values that don't really match up with the entire with like the rest of the data. And it just makes it so that the model can be trained more accurately. Now for the next step, we have feature selection, which where 9 feature selection methods were run. These include methods like running ML models, running correlation matrices, and etc., to extract the features, again, the columns from the data set, which have the greatest accuracy impacts on the final accuracy metrics. So as I said, we had 77 features in the main data set. We reduced that down to 18. And this is like a quick visualization of how feature selection works. You just cut down the features based on whatever works and remove whatever doesn't. Quick synthetic data generation. So basically the main data set was split into the labels, and each label was trained on a different GAN, and then GANs were trained with an equal number of attack and benign points to make sure that both the labels were represented properly. So to compute similarity, we used 4 different statistical calculations. Correlation basically talks about how dependent or correlated 2 features are. Mean correlation is the average of the whole data set, average correlation of the whole data set. Basic statistics is an aggregate of different statistical methods, such as cosine similarity, etc. And MAPE estimator is the mean absolute percentage error. And then all of these numbers were averaged to make a similarity score, which we'll see in the next slide. So after we, so 2 data sets were generated. These are statistics for the synthetic generated data sets versus the original data sets. All data talks about the data set with all the features, the entire generated data set, which took 2.4 hours to train and has a similarity score of 0.9 with the original data set. But with our novel method, where we use feature selection, we generated a data set with 18 features, and that only took 0.74 hours, and it actually ended up having a higher similarity score to the original data set than the full one. So 1/2 of our novel approach is already working pretty well. And another step that was done to ensure that the data is actually a lot like the original data is classifier scores. So ML models were trained on the original data set and then run on the synthetic data. So TabGAN is our main focus here. As we can see, the scores are comparable, or even in some cases higher than the original data set. So what this says is our data can reliably be used in modern day IDSs, as modern day IDSs also use ML models. Since we have comparable accuracy, it's good data. So just a quick walkthrough through the generated cumulative sums. So the blue lines at the bottom of each graph are the cumulative sums of the original data, and the orange line is the synthetic data. So as we can see, it can follow trends and information pretty accurately. So to conclude, we introduced a novel method for producing accurate and representational data for cybersecurity. We talked about how it can tackle 2 challenges of privacy preservation, which isn't a challenge anymore because the synthetic data is similar. It satisfies the same need that we needed from the original data, without sacrificing privacy. And class imbalance, since we trained GANs on the underrepresented classes and generated a lot of data for those, class imbalances aren't a problem anymore. And it can also be extended to other domains like predicting SSD failures, etc. And we aim to improve accuracy in the future. Thank you.
Thank you, Dheeraj. Any questions for Dheeraj? Okay, thank you. Up next, let's just kind of present her website, Beach. Are you gonna use your laptop?
Oh, no, I just have.
Nice. All right. This thing, did you email?
I submitted it.
Nice. Oh, it was- which one? This one. Yeah, we don't pay your machine. I think it's a-
Oh, we can, if we can. I don't know what.
Let's see if this works. The good one. Found it. Can you send me about video?
Yeah.
Having some technical issues with the LibreOffice.
Sorry.
There you go. All right.
We're good. Okay. Sorry for the technical difficulties. Hi, everyone. My name is Ozzy and I'm going to be presenting the website that I built. It's called Peach. So Peach is basically a buy and sell website for some secondhand stuff that you might have lying around the house. So basically, if you have a cluttered closet or a garage full of athletics equipment you swore you'd use every day but never touched again, or anything really that you need to get rid of that's around the house, Peach has you covered. You can post the stuff that you want to get rid of, hunt for cool stuff that others have posted, and then reach out to sellers to stake your claim on the stuff that they put out. So what led to Peach was basically the lack of a simple, easy to use buying and selling platform on the internet. While there are platforms out there, most of them are pretty complicated and they force you to jump through a bunch of hoops before you can put whatever you want on the web or even contact the seller that's trying to sell the product. I personally love to read, and over the years I have accumulated an unnecessary number of books in my house, which my mother is always complaining about. Because they collect dust in the back of closets, and she recently decided she wanted to sell them on the internet. But my mother is someone who asks me how to Facebook her friends, which means FaceTime, but and she's just incapable of going on the internet and jumping through all the hoops that she needs to in order to post something online. So I made Peach. It's super user friendly, basically mom proof. And it allows you to sell your products, contact other sellers, and keeps the whole exchange as simple as it can be. Some of the software I used was VS Code and GitHub to create, store, and post locally for the moment my code. Angular, Happy, and Node.js to actually create the code, and MySQL and MySQL Workbench to host and work on the database. Also, special shout out to Postman, which helped me do a lot of my double checking on my API calls. Here's a basic outline of which pages can be accessed from where. As you can see, when you log in, well, initially when you load up the page, you'll be faced with a login page. If you don't have an account already, you can access the registration page from there. But once you've logged in, you'll be able to see the homepage, which we saw earlier in the presentation. And from the homepage, using a navigation bar at the top of the page, you can access all of the other areas of my website. Within the products list, which I'll go into and we'll get to see what they all look like in a little bit. You will be able to see all of the products posted by everyone over the course of the existence of the site. And from each product, you can go into the product to view the product details. And then from there, you can access the seller's page if you want to message them or find their phone number, which is information that would be available. If you go into add product, you can add a product to your products. And from my products, you can both edit and delete the products that you have, as well as go into my profile to edit your profile information. So some of the features I have, we'll look at a little more closely. The registration and login, like I said, is very simple. There's just the most basic of information that is necessary and not asking for anything more. The login page would ask for just your email and password and nothing else. Another feature that I have is the creation of the product listing. Again, very straightforward, just a name for whatever object that you're trying to sell. An item description can be as long or as short as you want, as well as a price for everyone to be able to view. The other option you have is to browse other people's products. They would be listed out like this, very simple. You can see what's available as well as the price. If you were to click on the product itself, it would take you to the description of the product as well as the link to the seller's profile. And you can see the navigation bar at the top of this page as well. Viewing your own products / editing and deleting them would take you to this page where you can see all the information, click edit or delete, whichever you need to do. And also you'd be able to view the number of views, which would only be information available to the owner of the product and not other people, to see how many people have clicked on your product since you posted it. That's it. Any questions?
Any questions for us?
What would you do next if you kept working on it?
I think that I would add a way to filter the products based on distance from where you're located, or based on what you're looking for, maybe. But I think that I just want to keep it as simple as possible, which was the whole purpose of this to begin with. But I think a filtration would definitely help narrow down what product you're looking for and help organize the buyer side a little bit.
You also gotta do about messages, right?
Right, and the messaging system, right? So that you could use the actual website to message the buyer instead of just, accessing their phone number, which might be a step to make it a little bit easier.
Thank you, Adi. Who's gonna talk about asynchronous task queues for the language go? I see.
I just add in another window.
Yeah,
Might
that's,
have to go back to world.
yeah, let's go. Yeah, just.
Didn't want to come in, but also can show that.
Yeah. And you can just drag it to the right.
Okay, great. Hi, I'm Addison. I'm going to talk today about Zucchini, which is my library for asynchronous task queues in Go. So I'm going to start out by sort of motivating the problem here. So this is really a classic problem where we have one application server. This could be a web service, it could be some sort of API, but we've got this server and we're trying to respond to requests from n number of clients. So this could be 3 clients, or it could be, many clients, or it could be fewer clients. So when we have this problem, when we're dealing with variable number of clients and they're giving our server workload, we have this problem where sometimes our server's capacity is above what it needs to process that workload, and sometimes our server's capacity is insufficient for that workload. So how do we make up this gap? How do we fix this problem where we've got varying capacity and workload? Well, there have been a couple of solutions to this historically. Usually, we go for the simplest one, which is just add more capacity to our servers. And this is a great solution because it's really simple, right? We don't need to worry about a lot. We just add more capacity, and now we can process all of our workload. However, the problem here you can see is we've actually gotten a lot less efficient, because before we were already at times wasting capacity on our server. Now we're wasting even more capacity because we've just continued to expand our server without really keeping efficiency in mind. So another idea is to go serverless, right? Which is we can re-architect our application so we can push some of its functionality into the cloud. And this is really great because now we can have part of our application's functionality called instantly whenever we need it. So we're able to much better map the work we're executing to our actual workload. So this is much more efficient, but the problem it has is now we're having to deal with the complexity of using a cloud service, and that's not always optimal if we haven't set that up already. And another thing you could consider is using microservices. So maybe you've got, a monolithic application, you want to split it up into different services that can talk to each other. That's a good way to make your application more efficient, but it can also introduce a lot of additional complexity, and it's a lot of work if your application isn't already set up that way. So I want to ask, is there a different approach we can take for a certain set of applications? And that's really what Zucchini is designed to solve. So Zucchini is used to process background tasks in an efficient way. And I want to give you an example to motivate this. Say that you're an independent web developer, you've got some sort of contract with a tax accountant, and he wants to have a website so that his clients can upload files, images of financial documents that he can view. And whenever these documents get uploaded, he wants to be able to do some processing on them. Maybe he wants to standardize them in some way. Maybe he just wants to save them to some sort of database so he can view them later. But given that people might have a fair number of financial documents, this is a resource-intensive workload. And so you want to be able to offload these as background tasks, but you don't want to have a lot of additional infrastructure which you have to add to your application to do this. This is where Zucchini is really designed to shine. It's a built-in Go library which you can just drop into your application. And you don't need to make any changes to your code to do this. So what Zucchini does is it just wraps around a Go function and it's able to turn that into a task. It's built off of Go's own asynchronous primitives, which are Go routines. So they're really lightweight. They're not going to add a lot of additional latency to do this. It uses Redis internally to be able to process tasks and store the sort of state of the results. So it's not super heavy. And it's got a really simple API. So if you were confused about how to use this, you can learn it very quickly. And it also has a bunch of other features, like if your tasks fail, right, because maybe your task is calling some API and that API isn't 100% reliable, well, then it's automatically going to be able to retry your task, and you're going to be able to configure the logic for how those retries should happen. So for example, if you want to do exponential retry, exponential backoff for time, you want to wait, before each new additional retry, you can do that. If you want to set a maximum number of retries, you can do that. And if you want, to have the ability to cancel a task you can also do that. It also comes with a web UI, so you can monitor tasks in case you want to debug them as you're developing. You can see them actually as they're processed. So it makes it really easy from the developer point of view. So here's a high level overview of how it works. So in this example, we have a client which sends, task data to a producer. So if in the image upload example, that would be some like image data. And what that does is it sends that data to the consumer calls that Go function in another process with that data. And then once it has the results of whatever that task was, it sends them back over to the client. And then the producer can optionally call a callback function using those task results, or you can do whatever you want with that task data you got from running the task. So here's a demo. In this demo, it's how you might consider writing a basic task to do a spam check. So you see, we define a type of what data our task is going to process. We define a function, which is our actual task. So you can see it's a regular Go function, which just takes in that type. We can define a callback function, which is what's going to happen after that task finishes, and we can check the status. And then we are making the task definition using the handler for the task, the callback for the task. You can see we're specifying options like timeout, the task name, and max retries, what we want the retry strategy to be. Then we connect to Redis. We're going to create a task producer, a task consumer, and we're going to start, to create tasks just by queuing them onto the producer. Each of those tasks will generate a unique task ID, so you can use that to track the task in the monitor. You can also use that to cancel the tasks. You'll see we'll start to process those tasks. And you can see that from the monitor, we've got, task queued at the start, and we've got task processing. That's because in this example, we set the max concurrency limit to 5 for the amount of tasks to process at once. So you can see we've already started processing some of these tasks. We can see the ID and their arguments. The rest are in the queued state. And as our consumer processes these tasks, they'll be moved to the succeeded state, and eventually all end up there, except for the one you can see that we canceled. It got moved to that state, so it'll be there. So it's very easy to keep track of these tasks. And really, this is a way that we can manage the entire task lifecycle for small to mid-sized applications using this library, which just drops into Go. The other benefit of this is it's free and open source. You can go to GitHub, you can download this, you can experiment with it, you can use it. And really, you don't need any architectural changes to be able to drop this into whatever application you already have. So it's a really convenient and simple solution. Any questions?
Any questions for Edison?
If you think about for something that you retry it max number of times and then you can't successfully complete the task, do you have a dead letter queue, or what do you have in terms of a way to?
Yeah, that's a fantastic question. So it'll move to the failed state, and then when you define a task, you can also define a callback for what happens after that task finishes. And in that, you can check the status of the task. So you can write your own custom logic for whatever you want to do with that task failed. So if it's okay, I want to, just log this, you can do that. If you want to spin up, some alternative task, you can do that. So you really have maximum flexibility to do whatever you want if the task fails. But if it fails initially, you also will just, retry based on, what you've configured.
Any other question? Thank you. Next, we have Panic and Anya. They're gonna talk about their auto parts equivalent scoring and clustering analysis. Mouthful. It's a mouthful. Just drag it to the side.
Right, hello. Today we'll be talking about our senior projects, auto parts equivalence scorings and cluster visualization. This project is collaborated with Parsec, a real world company outside, and we're trying to solve a challenge that we're facing. Let me tell you more about this company. So Parsec is an online platform for ordering auto parts. Auto repair shop through this platform can check parts availability and order parts on demand. And once Parsec get this order, they will forward these orders to the parts distributors, and the parts they order will be delivered to the repair shop within matters of hours. And Parsec operates in a rapidly growing industry. As of today, there are more than 250 million cars running on the road, and with an age of 12.1 years. Now, I don't know about you, but I seriously doubt that anything we use on a daily basis can last more than 10 years. Those old vehicles will break down and they will need to be serviced at some point. And a compatible replacement part become essentials in properly performing the repair process. As a result, there's a growing needs for the replacement parts, and the US auto parts market value was estimated to be 17 billion at 2020, and this number is still expected to grow. Now, the major challenge faced by this company and even the industry is the inaccurate fitment information, meaning that some part that do not fit the vehicle that they claims to fit on. This is a really bad situation when the wrong part is delivered to the repair shop. So the repair shop has to return their parts, wait for another hours for the right parts to come in, and the warehouse have to restock the parts, send out another new one, and hopefully that will fit. At the meantime, their car just sit on the jack stand and no work can be done on it just because the part is not right. As we can see, this scenario is very inefficient and is still happening in the industry today. One thing I want to point out here is this situation only happens to a small number of parts. 90% of the time, the parts will fit the vehicle. However, the 10% remaining 10% uncertainty still becomes a significant challenge for Parsec, especially for a company like them operating at their scale.
All right, so talking about the main goals of this project, we have two major goals. The first goal is to identify the part that truly fits the targeted vehicle. And the second goal is to look into the interchangeability feature of the parts, because you might not always get the actual part that you really want. So you want to find something that's very similar to it, and you can still make it work in your car. So for this particular project, we've decided to focus only on one auto part, which is the disc brake rotor. And as shown in the picture here, a disc brake rotor might have a lot of different parameters. Could be inner diameter, outer diameter, number of screws, and many things like that. So in our project, we basically use most of the numeric parameters reported to find the solution to the challenges that Hanyang just mentioned about. So this cluster visualization that you see here is the solution that helps us achieve both of our goals. So basically what this is we visualize all the disc brake rotors that claim to fit an actual vehicle, Ford F-150 2010 model. So I'll go over the graph on a very succinct basis, which is basically all the nodes here are distinct disc brake rotors, and all the edges are the connections that they have. So longer the edge, it means that highly dissimilar they are. So if a disc brake rotor is here, and if a disc brake rotor is here, and if they are connected, then it means that they're not too similar. And shorter edge means that they're highly similar. So how does this help us? So to achieve our goal number one of finding true fitment, we need to look at the center of this graph and then find the node that has the highest degree, which in a way means that it has the highest number of connections. But I mean, having highest number of connections, how does that relate to the probability of fitment? So the main thing here is having highest number of connections with other parts that also claim to fit the same vehicle means that they will have more similar attributes, or even the values for the attributes will not vary much. Like for inner diameter, it could vary just by 0.1 centimeter or something like that. But when you calculate the whole score, then it doesn't vary much, which makes us claim that that particular part has the highest probability of fitment. Going into the second goal of achieving the second goal, you know, you say you go try to get one part, you don't have that part, but you still need your car to work, right? So in that case, you got to find that part in the middle of the cluster and then look into its surrounding and then see if they're connected and then choose the part that is closest to it. So in this way, you'll find the part that fits in and also is interchangeable, which helps us meet both the goals.
Yep. So how do we get to that? It does take us a long time to process all the data. We were given a humongous data file, and only a portion of those information are useful. So the first step we perform is to extract common parameters for all rotors, and we have to drop rotors with less information, meaning that we don't really trust the information provided by the other parts manufacturers. And we also perform unit of measurement standardization, so we can cross-compare different features, and we convert nominal data to categories, so we can compare metal parts and other types. At the end, we get to a data set consisting of 92,000 rotors. Each rotor has 34 parameters, and they all comes with standardized values. And after we get to that, we use cosine similarity algorithm to generate a similarity score. It basically changed the parameters into vectors, and once we put the vector onto our coordinate, we can visualize them and find the angular difference between them. The bigger the angular difference, the bigger the more dissimilar they are. And then at the end, we reach the score range between 0 and 1, and 0 meaning that the parts are highly dissimilar, 1 means that the parts are highly similar.
After we get all the scores, we use an algorithm called spring layout to visualize it. So it basically mimics a gravity model, as in like if there are two parts and the weight between them is higher, which means that they have more attraction force, as in they will be closer to each other, which is how we find that they're similar to each other. And then we use an open source software called G5, which is widely used for visualization, which helps us visualize nodes and edges. Like I mentioned, that we got to look into the node with the highest degree. G5 also has a data laboratory, which helps us do that. So lastly, coming to the major outcome. So how is all this going to help Partstech, which is the company that we collaborated with? Is number one thing is inventory optimization. Just put yourself in the shoes of a repair shop owner. You want to stock in something that has the highest probability of selling, right? So if people come in, then you want to give them something that has highest probability of fitment. So you can just put in that part. You can just stock in that part rather than buying different parts. So that way you can optimize your inventory, make more sales. The second point is versatility. We can extend our analysis for brand to brand. You can narrow down by saying, if you feel like there are two manufacturers which create similar auto parts, then you just focus your analysis on that. And our model is capable of doing that. And all of this will help Partstech search recommendation system. So as of now, Partstech is basically recommending you all the parts that they see in the database, which fits it. But this will help them narrow down the search and will also make the search more robust, which we claim that it will help them to retain customers better. And lastly, identifying parts with poor documentation. So all the parts that you see on the farther edges, it means that they are far from center because all the attributes they claim to fit, or the other attributes they put down in the database, is not exactly similar to all the major attributes of other different parts, which kind of gives us a sense that, okay, they might not be, documenting things properly. So as a whole, all of this will be helpful for Partstech as an internal tool and also as an external tool to attain more customers. So thank you. Any questions?
Any questions for Hanyan and Pranik?
What would be your next step?
We can't wait to test it on a build, and we didn't get to do it, and we have been communicating with Partstech, and then they're really excited to see how it's gonna looks like in the field. Couple more thing is we will also like to work on the data extractions. There's still a lot of data in the data set they provided to us, and we the data extraction for what we're doing right now is I would say we only extracted like 20-30% of the information out of it, and more robust extraction will allow us to obtain more data of rotors, putting more dots onto the map, making it even more robust.
Just to add on that, we also love to, extend the analysis to different parts, which was our initial thing, but due to time constraint, we just focused on one. But the same analysis and the same algorithm can definitely be used for other different parts.
Good work. Thank you.
Yeah.
Up next, we have Taka and George. He's gonna talk about their nurse scheduling tool, which they collaborated with M7. Thank you for the light. Thank you.
All right, my name is George and this is Tucker. Today we're gonna present our project, Smart Scheduler with in collaboration with M7. M7 is a startup within healthcare sector. So what with Smart Scheduler, M7 is trying to optimize the way nurses are scheduled right now. So the traditional approach is paper-based, basically spreadsheet and a lot of paperwork. So, and that is it has a lot of pain points. And the first one is it is time consuming, basically takes tens of hours to actually create a schedule for a different set of nurses. And sometimes goes up to 14 days to make a schedule. And then the other one is very tedious, both physically and mentally. So basically, like if you have, let's say, 70 nurses in a time frame of maybe a schedule of 40 days, so that is like a lot of work to do. And then the other one, it leads to that suboptimal results. So basically, the fact that the nurses do have their own preferences, so they have to work, they want to work maybe for some days, and other days maybe they don't want to work. So this approach sometimes doesn't lead to optimal results. Why smart scheduler? So the idea is basically want to save time. So from tens of hours right now, we can save at least take it down to up to 5 seconds using smart scheduler. And then the other one is transparency. So we want to be fair to the nurses. So we don't want to force them to work on some days, and some days maybe they want to be on vacation, don't want to put them on the schedule. So smart schedule is trying to obey that for nurses. And also we want to be fair to the hospital because they have their own objectives and goals as well. So we want to optimize the number of people that are working on maybe a particular shift. Another one smart schedule will do is basically it will provide like staffing metrics. Basically, we want to know, okay, this for this schedule, nurse X got, let's say, 98% of what they asked for, or maybe 70%. We can actually see was it optimal or not. So this is our process. Basically, from when we get the CSV file, basically the preferences for nurses all the way to the final schedule. The first time is basically read that CSV file. And then the other one is basically process that data to work with values that are easier to work with, especially we convert the text to numeric values. And then the third one is the heart of the algorithm, basically. So we are using internet programming technique. We're using a library called Pulp, which is a Python library to make the schedule. And then the last one is basically the format. So we're going to generate the CSV file for M7, and that's like we take the numeric values into text so that the nurses can see, okay, I'm scheduled for this day, or I'm going to have this responsibility depending on what type of nurse that is.
All right, so now I'm getting to the detailed part of our integer programming process. So the first component involves defining various constraints. For example, we have nurse constraints, and so for full-time nurses, we need shift visits. Then for part-time nurses, we need at least 8 shifts per month. And then in terms of shift requirements, we'll need at least one charge nurse will look over the entire shifts, and we also need minimum and maximum nurses per shift, which varies depending on the number of the nurses in the schedule. And then the next component is the nurse preferences. So for our schedule, we have 4 different type of preferences. The first one is protected, which means the nurse should not be assigned for that shifts. And then we have request off, which means the nurse can work, but they prefer not to be scheduled. And then we also have open, which simply means that the nurse can work for that shifts. And then lastly, we have day, evening, or night, depending on which shift type the nurse is assigned to, and that indicates that the nurse is preferred to work for that shift. And then for our programming process, we will convert all these preferences into numeric values, which then can be processed, which then we can use to apply mathematical functions to it. And then, so here after we convert to the number, we will multiply this number by the assignment, which will be either 1 or 0. And you can see that when we assign a nurse on a protected shift, it will generate the worst value. And then on the other hand, we assign nurse on day, evening, or night will result in the best value. So after we get this product, we'll add this product for all the nurses across all their shifts, and this will in turn become our objective function that we like to maximize, and we'll pass this objective function as well as all the hard constraint that defined previously into a pop solver, and that will mathematically generate the optimized schedule for all the nurses.
So this is a quick demo of uploading a CSV file of all the preferences and also up to the final schedule. So it is like a web page. The nurse manager can specify some input values. These are constraints. Basically, these are different type of nurses. Some work during the day, some evening, some at night. And this is the final output. This is the final schedule. So you can see some nurses are working day. Each show that I'm working a day, or maybe I'm working an evening shift or a night shift. And then the nurse manager can download the final schedule, and also we have another table that show what preferences were made for a particular nurse. So yeah, so this is the final schedule. And this is like a table that basically shows the metrics of like, this is what I asked for. That's it. Yes. You can also see the metric like, 90% of what I asked for was met or not.
Should click escape.
Yep. So the final one is like the future recommendation of the what would be the next steps. The first one we would like to maybe work on later is precise error handling. What we do right now in the algorithm, it basically logs everything into a file, and there's a lot of errors that are not very specific and actionable. So in the future, we'd like to see that, okay, the algorithm failed or the hard constraint were broken. We can maybe let the nurse manager know, oh, this is what you should do with this CSV file that you uploaded, and that's why it wasn't working or something like that. And then the other one is more testing. We need more data to actually see is it working based on the complexity of the preferences. And also, what about we maybe increase the number of nurses a little bit? Can it actually hit on that mark of like maybe 5 seconds or 6 seconds? So that's it. These are the resources that we use. Thank you.
Questions for Taka and John?
So did M7 actually use this with nurses and test it out, or all theoretical?
Yeah, they haven't used it so far. So so the next step with them is like they're gonna use it because like the is a startup, so they're gonna use it to basically like maybe for the pitching them to pitching this project to maybe their contributors and things like that. So that's the next plan for this.
Thank you, everyone. I need break now, there is some time outside, I'll get out. Restroom, break. And then back. Yeah.
I saw that name on the, your okay, sorry, okay, I got the. I was working with Parts Deck, it was fun, it was fun.
Yeah, and the senior.
Oh, that's cool, and so you got to actually work with.
Yeah,
Really the embedded part of their team.
Yes, 3 people actually. Initially, it was just Eric, you know Eric, right?
Yeah.
And then he hopped in VP of data, Barry, and then he hopped in other data analysts. So it was fun.
That's cool, that's a good learning environment.
Yeah, we have a final pitch to them on May 5th
Okay.
about like everything. And yeah, I mean, it's useful for them and they're trying to integrate it internally first and then check things out. But we still have to like go to the field and test, you know.
Yeah.
Okay.
But it was great, yeah.
Yeah,
Thank you.
good
Thank you for
experience.
bringing that.
Well, I glad it worked out. Parts Tech was really complimentary to you guys.
Yeah,
They said it was a really great project for them too. They want to do some more next year and so,
yeah.
yeah.
Good presentation.
Yeah, really good.
Yeah, they're thinking of testing it out in the fields after we submit everything. So that would be fun.
Yeah, I know, right? It's like something that you created,
Yeah.
it actually is.
Cool. Good job. And we sent you guys, by the way, we haven't executed the paperwork. So how is it working with them? Yeah.
Thank you.
No presentation.
哦，讲完了。哦，你跟谁？哦，是吗？哦，我拜拜。
I don't think you need to say that.
Nice job. All right. All right. I'm gonna send you guys a survey. Fill out, say what you
I think we should do that.
Students bring this down, so you get Eva. and
Good job.
keep that on it. Well, it's unclear when you go get a job. I work for a real company, a real firm. I prove them I can work hard the team, you know, it's a lot more than just something I would know. So that's really the role. I'm sure to be a resident. But you usually do that. Yeah, and there'll be more choice. There won't be enough students for the company. They'll pick, this year, so I'm gonna do a lot this summer. Yeah, I still have to send you guys by the paperwork this time. Okay. I'll send that to you. Yeah, I need to talk to you now about things we can do to make it better. We're gonna get started. I don't want to go back to it. People will be. State law, I'm in the connection, party. People can, yeah, I want that, you know, I had this part that I put here, part of the actually side, it wasn't side by side, that part of the data, what's the letter.
So, I had a link to the video and I'm yeah, the thing is, so when I clicked, I was just doing a little test run just now. And when I clicked on this, like, it was like,
It's not opening.
Yeah, bro, it was like, you're saying this.
Click on cancel. See. But I'll just-
Eventually it works, but they have to like pick plants a whole bunch of times, so.
So I would think, why don't you just switch?
Okay.
Like, just do.
Okay.
And then if we want to do this, just drag it. So
Okay.
that's the best option. I think whenever you see this, we put it there.
Okay.
And then before that, your. This is great. Okay, so just. Yeah, but then just.
Sorry, how'd you do that? Control F?
Yeah, control F, all the.
Oh, tab, okay.
To drag it to the right and then start begin the presentation. It will already show, which is fine, which is. fine,
Oh,
which is-
shit.
No, which is fine, actually. I think. You wanna look at it now a little bit, so whenever you're ready. Yeah. This thing is. Whenever you're ready, just drag it to that side, and you'll see it popping. And let's start, okay? And whenever you're done, you can just close it, and this will be it.
Okay, how do I access?
So click on slideshow. Up here, yeah. First. And then whenever you want to escape, and then you will have the.
Okay, cool.
So it's slideshow. Just escape out of it and that should be right.
Oh, okay.
Now. So all them to switch focus services, the other one. And it's great.
And that gives you like the space bar to hit play on the
Yeah.
video thing.
Let's check it out.
Yeah, I'm sorry about all this, like, because it was working on my computer, like,
Do
pretty.
you need to? I don't know. We have no idea.
I'll just talk through it, so there's no audio.
That's fine. So just start from here. Yeah.
Okay.
Okay, go ahead.
Hold on.
Cool, thank you.
Oh, Professor, would you rather, I have a Google Drive version and, like the version I submitted, would you
Those are
prefer?
docs.
I emailed you the link just now.
So that's better, the
Okay.
slides, right?
Yeah, slides,
that's
okay,
the
yeah,
best.
so, okay, so I emailed you.
Okay,
like,
yeah, I got
got
it.
Can I get?
Good work, yeah.
Yeah, just because I just walked around with a bunch of stuff and it's like all set up.
No, that's fine, it was good. Just worry about it.
Yeah, no, I just like
Just finishing the. Okay, that's good, that's good. So just one or two, and then we're.
Absolutely, guys. That's a special thing. Thank you.
What do you?
Not yet. That like, I haven't done.
I know.
We good, man. Good, all right, good to see you. I'm gonna try to come tomorrow. Yeah, I don't know how to shake. I don't know how to do it all right. What do you do? Okay. I'm too old to learn new tricks.
All right, let's restart our presentations. Up next is Colin, and he's gonna talk about his trade bot, which will help you find the right security stack.
All right, good morning. I am Colin Hawkins. I'm a senior computer science and economics major here at Trinity, and this is my project TradeBot that I completed with the help of Professor Islam. So what is TradeBot? It's basically just a public web app that asks the user a series of simple questions about their investment profile, such as risk tolerance, what sectors they're interested in investing in, what market conditions are like, as well as how much money they're looking to invest, and then basically prompt gives them a recommendation for one of 7 strategies that I tested, as well as a ticker to implement it on. It also includes a link to a GitHub repository where the user can download the strategy that was recommended for them, as well as instructions for how to hook it up to a broker API, which is how you would actually use this in real life with real money. And then there's also an informational section at the bottom of the web app. There's a bunch of tabs where basically just explains the logic of each algorithm that I tested, as well as what sectors they do best in. So I guess motivation and significance really quickly. According to Investopedia, high frequency trading, which is a subset of algorithmic trading, made up pretty much half of transaction volume on the New York Stock Exchange in 2013, and that was 10 years ago. So I mean, this stuff is the future is here in terms of algorithmic trading. It's definitely being used pretty widely by institutional investors that are pictured below. So if you have any interest in beating market benchmarks, you should be interested in this kind of stuff. And the niche that I'm specifically looking to fill is that there's not really a one-stop place where somebody who doesn't really know anything about the markets or these strategies can go get a recommendation, and then you just have really simple instructions for how to use it. So that's basically what the motivation was. Methodology, first there was just some preliminary research where I did sort of look at what strategies were going to be feasible, as well as just which ones would be cool to include in the project. Then I source and implement the selected algorithms. The reason I say source and implement is because to varying degrees, I implemented these. There were a few like the momentum ones that were, basically built from the ground up. And then there were a few others that, more complicated machine learning models that I got the logic off the internet or from some textbooks. Then I would test these strategies on different parameters. So mess around with things like window length, the number of regressors for the machine learning ones, basically the time periods, and then most importantly tickers, I guess. And then once I ran these tests, I used the results to define the logic for the recommendation algorithm for the web app, which I will show later on in the presentation. And then just lastly, just wanted to build like a professional looking UI just to present my findings. Just the technologies I used, most of the algorithms were in Python, so using NumPy, Matplotlib, and Pandas a lot. There was one algorithm that wasn't R. Angular and Node I just used for the web app. Jupyter was the testing environment, and I was pulling the data from Yahoo Finance. So strategies included, there were 7 strategies that I tested on. It would take me a really long time to explain in depth each of these strategies logic, but just really, I guess, generally, the first 2 are just simple momentum strategies, basically just operate on some simple rule. So I guess, for example, the EMA crossover strategy basically calculates 50-day and 200-day exponential moving averages of price data. And when the 50-day EMA is greater than the 200-day EMA, it basically signals to buy because momentum is up. That's just one example of the momentum algorithms. There's a couple machine learning algorithms, the logistic regression and Riemann-Gard convergence algorithms. Like I said, it would take me a really long time to sort of explain these, but basically just, running a series of regressions on pretty much all the data that's available from what I was pulling on Yahoo Finance. And then there were some really vanilla strategies, just like dollar cost averaging and buy and hold. These are pretty much just it's pretty self-explanatory. Dollar cost averaging is just putting in like a set amount every week or every interval, and buying and holding is just what it sounds like, buying and holding. So testing results, I have over 40 of these graphs on my computer, but I just wanted to pull a few just to show you, illustrate a few different cases that I noticed. So as it says, performance varied pretty widely, as you can see, but funnily enough, the most consistently profitable strategies were two of the simplest ones, the low close and the buy and hold. So I guess starting from the left, I really wanted to include this graph because it kind of shows, how powerful these algorithms can actually be. As you can see, 626% return when using the algorithm versus a 44% return when not using the algorithm on Vanguard's real estate index. This is probably like the most drastic difference in performance that I noticed. The one on the low close on Amazon, I wanted to illustrate that it's really hard to beat buy and hold when you're looking at growth stocks. Like Amazon obviously is their stock price has exploded exponentially since the mid 2000s. So that's why the buy and hold, which is represented in blue, is so high, and just the algorithm just really couldn't keep up with that. The exponential moving average on Vanguard's energy index, I included this one just because it really illustrates that you can kind of manipulate the results basically just based on what time period you're testing on. So for example, as you can see here, the strategy is definitely outperforming the buy and hold by a significant margin. But if I was doing this test in 2015 rather than 2023, you would think buying and holding would, drastically outperform the algorithm. So I just wanted to illustrate that. And then the last one on this page, the EMA on Bitcoin. I just want to include this because crypto is often super popular and it's pretty hard to beat buying and holding, but this one the EMA managed to do so. So video demo, I actually have I'm going to show off this is the user interface, and I'm just going to show you some basic features here. So the users basically ask these questions. Once they finish answering all the questions, they're going to be provided with a recommendation for a strategy as well as a ticker, basically for what to trade on. So as you can see, there's probably just a few use cases here. And then as you can notice on the bottom, there's tabs for each algorithm that I tested, just basically saying here's what the logic is and here's what sectors it perform best on. As well as in the About Us section, there is a link to the GitHub repository. Back to demo and then limitations of future work. So I guess the primary limitation that I had was a lot of the strategies that I was researching used data that was from intervals of less than a day. A lot of algorithms use minute data, 5-minute data, hour data, and some of these strategies were really interesting and had really good results from what I was looking at. But unfortunately, the source where I was getting data from, Yahoo Finance, they don't really have data on intervals shorter than a day for periods past the last 2 years. So it kind of makes it hard for me to backtest and accurately assess the performance of these algorithms. If there's a way I could get access to that data, I definitely would want to play around with some algorithms at different time intervals. And then future work, I would have really liked to include some more advanced stuff like the LSTM model. I think Professor Islam was, pretty passionate about that. Unfortunately, there was, due to when I was starting to think about that, I didn't really have much time, but definitely something that I want to look into. That's kind of where the industry is right now, is neural networks and LSTMs. And then just, I guess, make it more publicly available. I want to like hear what people think about it. I want to hear people's experiences using it and, hopefully it's helpful to them, but I would like to make it like, just available for users. So, yeah, just, thank you guys.
Who wants to get rich?
I thought your points about though, when you measure, when you actually look at the time frame can yield different perceptions as to your success or not. I thought that was very insightful.
Yeah, I mean, it's definitely just something you want to pay attention to because like I said, like you could really just like totally misrepresent the performance of the strategy, and like that's definitely something I wanted to avoid. So that's a big part of the reason why I didn't want to test on like algorithms in shorter intervals, because I was really like, how can I accurately like sort of assess this performance about comparing it like on an even playing field to everything else. So.
Good job.
Thank you. Next, I'd like to invite Ian. Yeah, link to it. Message. This. Submitted to. Oh, I see. Yes, yeah. Started this one. Yeah, that was right. I talk about its app for safety of vehicles.
Hello everyone, I'm Ian. Today I'm going to be talking about my GPS speed limit monitor. First I want to talk about the motivation behind my project. So speeding is very dangerous, but it's very common. Over 40% of people said they speed on a regular basis. It's also a factor in a lot of car accidents. So it's a very dangerous behavior, and it's especially common among young drivers, people who first start driving. So my product aims to help parents monitor their kids driving, and the driving habits that it monitors include speeding, fast acceleration, and harsh braking. So first I just want to go over like how my app works. It's basically two iOS applications, one for the kid, one for the parents. So first I want to start with the one for the children. There's a login page where you can enter your username, and then there's a map view, which essentially tracks the user's location. It follows it around, and it shows the user's speed on the bottom and the speed limit of the current road on the top. This view isn't really necessary. You can run the application in the background, which is how it actually be used in practice, but this was useful for testing, and it's also nice to get like visual feedback. Like there's visual feedback if the user breaks the speed limit by over 10 miles per hour. Another functionality that the children's app has is you can add or delete who you want to be able to monitor you via their username. So that's what this view does. And then the parents app is pretty simple. All you do is log in, and then if you're monitoring anyone, you can view a list of their incidents, whether it's fast acceleration or speed limit braking. And you can view a variable number of people if you have if a parent has more than one kid or anything like that. So the technologies I used were Swift for the UI. I used the Bing Maps API to get the speed limit for the current road. I used Express for my server, and then I used MySQL for my database. The way the Swift, I'll go over like a chart of how it works later, but basically the key points are: one, I needed to simulate driving, because I'm not gonna go out and test this myself. So I just used a GPX file, which is basically an XML file with like a list of waypoints, and then how it simulates movement between those waypoints. I used the CL location manager, which is built into Swift, to get the current location. I calculated the current speed, and then I had one object that pretty much had all my functions on how to interact with the database and update the database. So this is basically how it works. The first step is getting the current location and a previous location once every second and calculating the current speed based off of that. This is pretty simple. The next thing I do is I send the current location to the Bing Maps API, and that returns a speed limit to my location view model, which is just essentially like one object for the entire project. And then I update the database with the current incident, whether it be fast acceleration, which is basically going from 0 to 30 or 0 to 25 in under 1 second, and fast braking, which is decelerating from 0 to 25 in 1 second. And also speeding, which is going over the speed limit for more than 10 miles per hour. And that updates the database. So for the other app, the parents app, it's really simple. I just send the current username to the server, and the server returns a list of incidents, a variable number of incidents for the users that you're allowed to monitor, basically. For the server, it's basically really simple. It wasn't as simple. I started off having like kind of like a janky server, but then I fixed it to be basically just one query method, and then that queries the database, and then I have a helper method for turning usernames into user IDs, and then I can update and delete each. I can update and delete data from each table. So the key methods are update incidents, which updates the server with the current incident, whether it's whatever type of incident it is, and then get incidents for the monitor users. So the database is really simple. It's basically a users table and then a monitor users table. I had a different table for them. And then there's the incidents, which basically just stores the location of an incident, the speed limit, whether it's applicable, and then the owner ID and the username of the user who's the incident it belongs to. And then for the user map, I basically just mapped different IDs from monitor users to regular users. And you can have like, for example, you can have users that monitors multiple users, and you can also have users that are monitored by multiple users. So the results, like I said, there's 2 iOS applications. That wasn't the case at the start, but I figured it would just be the most simple option. So the monitor app has the ability to display the incidents from the users that user can monitor, and it signifies what type of incident it is. And then the second app basically just collects the data from the user and then updates the database. And obviously you can manage who can monitor you. The challenges at the start were basically just learning these new technologies I'd never used before. But it got more interesting later in the project. Once I gained more experience using these technologies, I was able to go back into my code and make it cleaner, basically. So that was probably the biggest challenge towards the end of the project. So work remainings or limitations. So I wanted to add real-time alerts, but the time frame didn't really work out. And then authentication is another thing that sort of towards the end of the project I started considering, but then I didn't really have enough time. But other than that, the features this app offers are actually pretty competitive with like the current market of like parent monitor apps, especially with the addition of like the fast acceleration and harsh braking. That's not something you see with all the other apps. But it was just an effective project at learning these new technologies. Any questions?
Any questions?
Did you look at anything, were there other apps on the marketplace that were like this? Did you learn anything from those? Or?
Yeah, that's where I got the idea for the fast acceleration. I saw like not all the apps had that, only a few did, so I wanted to add that. But basically, the apps are really similar to this.
Thank you. Next is Mehmet. Quick switch.
good morning, everyone. My name is Mehmet, and I'm going to introduce you my senior project called Trading Dimension, which is a web-based VR application that lets you analyze stock market graphs in your own personalized trading dimension. So the reason I chose this topic, trading, is because we're experiencing the highest inflation levels in the last 2 decades, and in order to stop value loss of your money, you have to invest in the stock market. And also, with the effect of COVID-19, the government started handing us stimulus checks, which then people started investing in stock market. And in the last 2 years, the number of retail investors is now over 100 million. And that's also, the retail investors are also my focus customer group, because there's a lot of demand in that area. And in trading, you right now as a professional with professional investor setups, they're like a lot, you have to spend a lot of money, and I want to get rid of the gap between professional and retail investors. And also another problem with the existing condition is you can't really compare multiple graphs at once in the other apps. And there are like some that lets you do it, but you're still limited to only one screen. So the data is all crumbled up and you can't really see anything if you want to have like more than 3 or 4 graphs. And another problem is also accessibility. There's only 3 VR apps that lets you analyze graph in the world. And one of them is FlexTrade, which they've been trying to develop since 2017 and they still haven't released anything. And another one is Swissquote, which is like really weird. They're only available in Switzerland. So if you don't live in Switzerland, you can access to this app. And one of the most successful one out of these 3 is the Quant VR. But the problem with this one is you have to pay $60 monthly fee in order to access this app. And it's also not web-based. So you have to get a VR or like Oculus, which would cost like $300, $400. So some of the benefits of Trading Dimension is it eliminates the cost of equipment, because you use the VR technology, which is for you to just create objects and use them. And with that technology, you can just compare multiple graphs at once. And you also have unlimited screen space, which you can have your data represented better. And it's just a web-based app. So if you have like any device that connects to the internet, you can just put the URL down and access it from your browser. Now I'm going to explain what are some design and development steps. It's like a big project, so I wanted to just put it into smaller chunks, and I turned into 6 smaller steps. First one was to create the 2D user interface, and then the second was to turn that 2D design into 3D. And then once I had that 3D world, now I wanted to add the camera angles and movements, so like you can go around and look around in that world. And then after that, I added the stock charts. And then after adding the stock charts, it's a personalized trading dimension, so you want to interact with it. And then I added the user experience functionalities. And then lastly, I wanted to host it on the web so everyone can access it. I created the web structure using React, which helped save me a lot of time connecting between HTML, CSS, and JavaScripts. And then after creating the web structure, I created the VR environment using the 3JS library, which uses 5 main components called mesh, scene, camera, render, and canvas. And I also added lighting to make it look more realistic. You basically mesh objects are like basically your screens, objects on the screen, and then you add them in the scene using XYZ coordinates and put it in the scene. And then camera lets you see them, and then renders it 60 times per second. So let's say you moved, so it gets the new position, renders it again, and you see it on your screen. And everything is represented in the canvas. Now I'm just going to go into more detail about how these objects were created. The mesh objects, basically geometry, you just put a geometry and material. And for the screens, I use rectangular prism, which is in 3JS library called box. And then you just add some dimensions, how high you want to have it, how big you want to have it, and you just add the material and it automatically creates the object for you. And then I added the lightings, which was necessary. As you see on the left, it's with lighting, and then on the right, it's without lighting. And how you create it, you basically position the lighting on somewhere in the world, and then it takes 2 parameters, which is intensity
And then like, let's say you chose 2 and 0, it starts with the intensity of 2 and then starts slowly start fading away to the 0. And then I created a camera, which takes 4 parameters. You have your field of view, which is like the angle of how you see it. And then you have your near clipping plane and far clipping plane, which is basically whatever you have, whatever objects you have in those 2 planes is what you can see. And if you're out of it, let's say you moved and the object went out of that plane, then you can't see it. So it mimics how you see it. And then lastly, you put everything together in your canvas. You just add elements into the scene and you positions for the XYZ coordinates. Since it's a 3D world, you can choose anywhere in between the scene and you place your objects, and then you add your camera to the scene. And then for the stock market graphs, I created a function, took 4 parameters, the screen name, and then I had the coordinates, XYZ coordinates to position the screens, and then the rotating factor, because some of the screens are angled towards you, so you have to add that too. And then lastly, your desired stock ticker, so you can have your personalized stock. And then I added that group to the scene. I'll show a little demo of how this works. You can look around and then just right, left, up and down, and then you can also zoom in. And then you can also like specifically zoom in the graphs and move in the graphs too. You don't have to just walk in there. And you can also like do all of these for all those 6 screens, or they'll work together. And then you can, if you want to change the stock ticker, you just go to the search bar and put the one you wanted. After you change it, you can still update everything. And then you also have different indicators, which helps you trade. You have more than probably 50 indicators you can use. And then you can also change the representation of data. You can use a line where, let's say you didn't like candlestick, you can change it. There's also different time frames. It's like from 1 minute to 30 minutes to an hour. And then once you personalize it, you go into the VR mode. And one problem I had with this is I used iframe library, which for some reason got rid of the background and I couldn't really fix. And you can also, same in the VR mode, you're in the other one, you were fixed into a position, but in the VR mode, you're not fixed into one position. You can walk into the objects, like back out, look around.
Any questions for Amanda? Any question? How do you scroll inside the graph? Do you have your hand thing to control?
You can use your mouse, but when you have the actual, like say you have Oculus, you have those like sticks that you can move in, and then there's also like a button you can like zoom in, and it automatically goes in there.
Thank you. Maxwell and Gabe was gonna talk about the fitness app. Oh, you want sure you can. You cannot have a class at 10 today because we have the class till 10:40. We have a senior seminar till 10:40. It's okay. There we go.
Hello, everyone. Thank you for being here. Today we're going to tell you about our app that we've created called Lifting Ledger, which just helps you track your workouts.
So the motivation behind this project is that me and Gabe both enjoy to work out, and currently on the market, some of the ways to track your workouts, such as the way I previously used pen and paper. There's some problems with this. The pen you can lose the pen, the paper can get wet, and it'll really kind of hurt the progress tracking of your workout. So we wanted to come up with a solution that would cut all these issues out.
Yeah, I mean, personally, I would just try to remember what I did, and clearly that's a terrible solution, not only for working out, but also for tracking your progress. I mean, I can't remember what I did 2 weeks ago, so clearly there's a flaw with that method.
So for an introduction into Lifting Ledger is we want to deliver two main things, a free to use application and a user interface that cut down on all of the unnecessary features, providing valuable key features to users to track their progress through their workouts. Most of the workout applications on the market right now, you have to pay large fees such as Whoop, $299 a year in order to use it. And then also at the same time, they have a lot of applications, I mean, not applications, features through Whoop that clutters user interfaces, taking time up for users that just simply want to track their workouts.
The technology that we use to develop this application is a mean stack, which is a really good framework for developing web applications. The Angular is the front end, which is kind of what the user is interacting with. Express is the back end, Node is the server, and Mongo is the database. And this just allows for really dynamic web application development process. So I was going to give you a little demo of our app. So when you log in, this is what you'll see. You a little profile, your name. This is my brother's account, but and you can add a new workout, which is just to save some time. We've already gone ahead and made one here, which is called demo. So when you click on it, it'll show you all the details of the workout that you're going to do, such as the exercises, how many of them, and with what repetitions. So we'll go ahead and start this workout. So for the first, I'm going to do bench press. Here I can see I'm going to be doing 2 sets of it. I'm going to be doing 10 reps, and in the notes here, I'm doing a 4-second decline. So it just gives me a really good understanding of the workout that I'm going to do. So now I'm going to do 100 pounds of this. I'll go to the next exercise. I'm going to be doing the second set of bench press, this time only for 5 reps. And I'm going to do 125 pounds here. So I'm going to move to my next exercise. I'm going to be running on the treadmill for 10 minutes. In here in the notes, you'll see I'm doing it for 5 miles per hour. So I can just go ahead and start the timer. And this will count down, let me know. It's gonna, and then I'm doing sit-ups for another minute. I can start the timer again. And then when it's done, it'll let me know. And then if I go back in, I kind of want to track some of my statistics. I can click on this workout again. And down here, you'll see I've completed the workout right now. I've lifted the maximum of 125 pounds in this workout, and I've only done it 1 time. So here you can see you can create a workout, you can perform a workout, and then you can view your past workouts. And another feature which we're really happy we were able to do is the Explore Workout feature. So here we've kind of cleared the database just so it's not cluttered, but you would see every workout that anyone else on the application has created. And obviously, if there's like a public application, there'd be many workouts. You could search one here. And let's say I want to do Max's Friday lift. I can go in here, look at I can go in here, look at his statistics, look at his page, and go to his workouts. Go to this one and then import it into my library. And then when I go back to my workouts, it'll appear here. And if I want to, I can look at it, see all the workouts he's done, edit it at all if I want to, and then do it. So that way it's a really great socializing aspect of it. And then if I went back to his profile, I'd also be able to see all the workouts that he's doing, just to kind of keep up with each other. And then also if you go to my own profile, you'll see some of my statistics. You can edit any of your personal data. And then you can also look at the workouts I have. The green here means I've done it. The red means it's still pending. So it kind of just allows for that feedback loop there.
So some real world applications, we create this for people like us, and a great application for Lifting Ledger is for student athletes. And through the like the sharing your workout section and the account feature, you're able to send summer workout packets, like a lifting coach, to their athletes that they're in charge of. And this will keep teammates accountable and motivate teammates, because you can always check on the person in your position. If they're lifting more weight or doing more than you, then you'll be able to see that. So it'll keep them accountable and motivate each other.
Yeah, and Max was a lacrosse player here. I'm kind of just a typical guy, so I can kind of speak to that side of it, which is, you know, just general fitness is great, keeping track, you're really optimizing your time in the gym, which is important when you're a busy student or a young professional, you don't have time to kind of pay for those apps. Also, as in just socializing with friends, I mean, we're about to graduate, which is sad, but I'm looking forward. I've kind of had a good group of friends here. We like to work out together, so allow for that interaction going forward. And also just tracking workouts over time. This is a great feature, along with kind of the motivation and the accountability that goes along with the student athletes.
So to get some feedback, we deployed our lifting ledger application to 10 of our friends, and each of us did it. So we had 12 total people that used the application for a week. And then at the end of the week, we sent out a questionnaire asking a few questions. And we asked on one of them, what was your favorite feature of lifting ledger? And not surprisingly, downloading the other users' workouts was the crowd favorite. And then another question we asked was lifting ledger a better alternative to your previous workout tracking method? And a lot of people said yes to this question, comparatively to the expensive applications that some people have been using. I imagine that those are what made up the no section of this.
Yeah. So I mean, in conclusion, we were just really happy that we were able to create this product. At first it seemed really intimidating, but we're really pleased with what we have. And if any of you have the desire to track your workouts with our application, you can feel free to scan this QR code. Thank you very much.
Any questions? Or I hope it was.
Just a little, well, I sort of would have thought that primary feature would be that you guys want to see your historical stuff graphically, like how you did on, you know, one machine and how you were going up and improving or something.
Yeah, so that's actually, I mean, we intended to do that, and then kind of once we got into the logic of it, it was a lot trickier to implement than we had expected, in part because let's say for the bench, like for the bench press, for example, you're doing 2 sets. So then it kind of, you're doubling the data of one exercise. And also if you're editing the data over time, like I might do 5 sets this week and then 10 sets next week when I'm editing it. So it's not really fair to compare that. So that's kind of ultimately why we just went with like the max, which obviously PRs are not everything when you're working out, and we don't want to kind of propagate that idea. But I mean, if we had future time, we would have kind of thought out the logistics of it a little bit more, but
yeah, for future work, if we had to say what our future work was going to be, that would be our number one, is finding a way to add a visual statistics page to our application.
Thank you, though.
She's gonna present her app on wine. Yeah. Yeah. Did I download or? Little bit. We should check out Google Slides. Allow access. And input the link. That's good. Just back.
Okay, so today I'll be presenting on my senior capstone project, which is called Why Not? And my advisor was Dr. S. So the goal for my project was to create a user-friendly iOS application that improves the process of learning about wine through personalized recommendations. So what do I mean by improves the process of learning about wines? A lot of the time when you're trying to learn about new wines, discover new wines you might like, you're more than often not going to pick out a wine that you don't really like. Not a lot of the time you're going to see people online reading sommelier reviews, trying to understand what they've drunk before and what they might like in the future. So this app tries to combat that through personalized recommendations. So basically what happens is the user, based on their previous experiences, will keep getting recommendations from the application of new wines they should try. And through this, hopefully only progressively try wines that they like without having to waste any money on a wine that they don't like, which could potentially deter them from their learning process. So the technical specifications for this app, for the front end to build a mobile iOS app, I use SwiftUI and Swift. And for the back end, I use Python. I use a Word2Vec model that came from Gensim and sklearn to create the nearest neighbor model. And I use Amazon Web Server to integrate the two of them together. So the backend was used to create the recommendation system, and the front end is for the user interface and user experience. So this is the journey of my development over the past 9 months. So I started with learning Swift and SwiftUI to create the application skeleton. This was actually one of the main reasons why I chose to do a mobile app over a website. I never had the opportunity to develop a mobile app before, and I thought this would be a really good time for me to learn and gain those new skills, especially with the new use of SwiftUI being very prominent. Next, I developed the wine recommendation model using word embeddings, and I will explain that later on in the next slide. But I developed this model in Python using Word2Vec, using Gensim, using Pandas, and just a bunch of machine learning and AI processes, including natural language processing. Next, step 3 was to use Amazon Web Server to integrate the model into the SwiftUI using Lambda and S3 buckets. And this proved a very difficult part of my project for me, as understanding how to deploy all of that was a bit of a learning curve, which I found out while I was trying to do it. It ended up being fun, and I actually learned a lot through that too. And finally, I just finished off the SwiftUI to make sure that I was able to show the user recommendations well and in a neat, clean way that has a sleek interface for the user. So I wanted to go into a little more process about the little more detail about the word embedding process, as that was a really important part of being able to process the reviews. So for my data, I actually took reviews that were scraped from the internet from winemag.com. I thought about using the scraper myself and implementing it myself, but it just seemed a little bit out of the scope of my project. So I didn't decide to do that. I decided to use the already scraped information. So basically, I had a file of all of these different wines that included the name and a review from different sommeliers and different people were reviewing them. So the point of word embedding is to ensure that although different reviews might have different personal styles written into them by the person who's writing them, word embedding processes it down into its base words and allows all reviews to be standardized between them. So we can see here what starts off as a lengthy, like couple sentences of a review with all these fluff words, such as this wine hails from what's soon to be a new Malibu appellation, which is not at all really relevant to the taste or the experience of drinking the wine, all gets removed. And it gets processed down into marshmallow nut, candy, mango, coconut, pineapple, and butterscotch, which are essentially the main aspects of the wine that is relevant to how it tastes and the experience that you're going to have with it. So this process occurred in every review, and with these word embeddings, that's what the Word2Vec and the vectorized space was created from. So next, I also wanted to explain how the recommendation system works and how the user feedback loop works. So what happens in the app, you see here, this is the UI for user to input their feedback on their last recommendation. So they're able to write what they enjoyed about the wine. Maybe they liked how, maybe they liked the acidity or the sweetness or anything like that. They're allowed to say what they didn't enjoy, and they like to say what they would prefer. Then once that data gets put in, it gets pushed back into the AWS and that gets pre-processed and it gets processed again with that same word embedding technique. So once those words have been determined from the user input, this will adjust the wine that is being recommended to the user. And basically how that works is a little bit more complicated, a little bit too deep for me to get into right now. But based on the user input and the word embeddings that come from that, the model is adjusted in the back end. And so once that model is adjusted, it generates a new recommendation in which the number one recommendation is presented to the user in this way in the app. So this is an analysis of the recommendation system, just using any wine in the data set, just using a random wine. This shows the first 100 wine recommendations that are the closest to that wine. It's actually in order of name by the bottom. So what you can see here is these are the cosine distance of the recommendations from the original wine. And this shows the similarity of the original wine to the wine that is being recommended. And in the app, I'm only recommending the top number one wine that is being pumped out through the model, but here we can see the top 100 wines. So even up until the 100th wine, there's only a 0.18 cosine distance between the original wine and the wine that is and the 100th recommended wine, which shows that with the large data set, the wines that are being recommended are actually very close to the original wine that we are aiming for, showing that the similarity between the wine will be accurate and hopefully the user will enjoy it. So here's just a quick demonstration, hopefully. Yeah, so this is just the generic opening homepage. And now we see that the user can see their last recommendation and they can see the description that comes with it. After this, the user can input what they liked about it. So here in this example, they like the sweetness of the wine. And let's say they didn't like the acidity of the wine. And they are able to put these and input these in. I think it's also important to show the recommendation and the description of it above, so a user can reflect on what the wine was and, remember that. And after that, they are able to see the descriptions of the wines down below. And they are able to see other wine recommendations down below.
Any questions for him?
What's the backstory for this? Why did you do this project?
Growing up, my dad was always very into wine and I never really knew anything about it. I didn't really know how to get into it or how to learn about it. So that was also a problem for me. So I wanted to create something to, kind of streamline that process, something that I would want to use myself actually. On top of that, while we were creating our ideas for this project, we were supposed to reflect on projects we did in the past. And when I was in high school, I wrote a paper about creating regression models to predict wine, predict wine qualities based on, So I'd already done a project with a big data set of wine, and I originally thought I was going to be able to use that data set of wine, but it didn't work, and I actually had to switch over to natural language processing and taking the reviews in and looking at those to create the recommendation system. So that was also one shift that occurred actually very early into my project. But yeah, it was a lot of personal reasoning behind it. Yeah, George.
How do you deploy this on App Store or not yet?
No, I'm trying to figure out if I can do that. I think there's still some things I want to improve on it. I'm trying to do a user login logout. I think that was a bit outside of the scope of my project. But just over the summer before I get a job, I hope to be able to flesh this out and expand it as much as I can and hopefully deploy it. And yeah, and then obviously I'll upload it.
George, that's not the show. Any other questions? Thank you.
Thank you.
Last but not least, we have Kaylin. She's gonna talk about her health and wellness app. Her app is already on the App Store called Rise.
Advanced fitness data.
Rise Fitness. Drag, yeah. Other side, other side.
Okay, welcome. I'd like to introduce you to RISE, a recovery intensity strain evaluation iOS application that's going to provide advanced fitness data and help you rise above. So the motivation for this project came out of me being a student athlete and utilizing my Apple Watch when I was running or training or just doing activities. And I love being able to collect that data. What I found was it's a lot of individualized metrics. So it's going to be things like calories burned, miles run, steps. And that doesn't really give you a good overview of your fitness and where you want to be with your goals. There are other applications like the Whoop, Peloton that are going to give you these analyzed fitness metrics like recovery and how hard your day was. So I wanted that data, but I didn't want to pay the price tag of like $30 a month or $40 a month without even having that equipment. I already had all the equipment I needed, but I didn't have that analyzed fitness metrics. So that is one of the goals of this project, is to provide the following metrics of recovery from sleep, intensity of workouts, and daily strain of activities. I'm also an interdisciplinary computing major with studio art, so I wanted to display the data in a visually intensive and interesting way that users could also understand. The resources that I used were Apple's Health Kit. This is where all of your Apple Watch data is stored, so you can pull things like heart rates and steps walked and all the different data that is collected with the Apple Watch. I also used Swift and a SQLite database to store all the metrics that I calculated. So my 4 methods were focused on recovery, intensity, strain, and evaluation. So for my first methodology for recovery, I used Apple's sleep analysis, which is going to track the time that the user is in bed for. So unfortunately, Apple Watch users, for all that have an Apple Watch, they know they charge it at night because the battery is just similar to your phone. So I couldn't pull heart rate data for this recovery metric. So I used the sleep analysis that's going to take haptic sound around your phone, as well as phone usage to decide when you're going to bed and alarms of when you're going to wake up. And that calculates the total amount of time in bed. So I found the time in bed and then also allowed the user to input a sleep quality. So this depends on how many percentage of the night the user is asleep for. And then I compared that to the CDC recommendation of like 8 hours a night. And so my feature, to show off this feature, so it opens from the store, and this night the Apple's analysis wasn't exactly accurate, so I actually can go in and change those hours. So I changed those hours, but also on the home page, once I press done, this is Apple's API privacy that allows you to see which settings are being read, so users feel comfortable with that. And then I can also go in and set the sleep quality as well. And that will change with my visualization as well. So I had a 79% recovery. It's not great. Next, for the intensity, I took workouts that are tracked actually using the Apple Watch, so the user doesn't actually have to go in or change what they're like how they're logging their workouts. So that each workout tracked by the Apple Watch has a heart rate sample. These samples are taken every 1 to 5 seconds, so they're very accurate. And there's a lot of them too, especially if you're working out for an hour to 2 hours. So I took those heart rate samples as well as I queried a max heart rate for the user. So this was over from the past 6 months of heart rate data, max heart rate is found. So these are all the different intensity zones that are tracked. And so the heart rate samples are compared to these different zones and given points for how much time is spent in each zone. The points are assigned based on how hard the user has to work to get from one zone to the next. So if you're working in a light zone and want to get to extreme, you'd have to work 8 times harder. And this is based off Peloton's own Strive score or intensity score. So the total stress points are then found for the time in each zone. And then this is mapped to a 1 to 10 scale using a logarithmic function. Whoop also uses this, and a logarithmic function best models workout intensity because the harder you're working, the harder it is to keep up that effort and to actually increase that strain. So a logarithmic function models that best. And a 0 to 10 scale is just easier for users to understand rather than like a total amount of stress points. So here's a video to show off this feature. First, I query the resting heart rate and current heart rate, and the max heart rate takes a little bit of time because it's 6 months of heart rate data. So that's millions of heart rates being tracked. And then I populate the screen with 2 workout intensities that I had for the day. The time is around 5 to 10 seconds, and this is because thousands of heart rate samples are being queried. Next, for daily strain, so I sum the workout intensities that the user tracked that I just talked about. And then I also apply a workout intensity for any times that you're not tracking a workout and your heart rate is actually elevated. So I query all the heart rates during the day and find when your heart rate is being elevated. This could be walking upstairs, giving a presentation, being stressed out, anytime your heart rate is elevated. And then I subtract the hours that the user is inactive. So that resting heart rate that was queried before is used again here to decide when the user is just resting, sitting down, doing work. So this is an example of this. So the inactive time and elevated time is actually displayed on the screen. This again is querying thousands of heart rates. So it does take around 5 to 10 seconds to load to the screen. So here you can see my inactive and active time, and then also a final strain. Now I'd love to show you on my phone, but unfortunately this morning I did not have time to work out. But last night I recorded a 76% recovery. I slept for 6 hours. That wasn't great. I actually walked here, so I tried to record that. Again, my heart rate wasn't very elevated, so it's only about a 0 intensity. My strain, I've only been sitting here in class, so a strain is 0. But I also have my last weekly recoveries as well. And that's my next page is the evaluation. So I used a charts framework and saved that data to a personal database. And so now I actually give the user their weekly metrics so that they can actually analyze their last week's worth of work. Again, it gives a little average too, and just more insight to their overall fitness. So some user experience results is that I'm App Store accepted. I'm on the App Store. So this has helped me distribute the app to as many people as possible. I did a small launch just trying to get friends and users to use it. And overall, they found that there was a faster load time than competitors. Right now, Whoop is around 5 to 10 minutes. You have to wait for your data. So if you wake up, you're going to have to wait, a significant amount of time before you can even see how well you slept the night before. So I would actually want to continue to increase, make this a little more seamless and smooth, just because the lag time is just one of the slower things on this end. But right now I am faster than competitors. And then overall positive feedback and daily usage has been great. I use this app daily with my training and work. I know my friends do also, and they've said that it's actually really helpful, and it's also a free option. So just some concluding thoughts was that I was able to accomplish my goals of the 3 metrics tracked and visualizing the data in an interesting way. And it's also free for charge for users so that anyone can use it, and it's not just gatekeep to the people that can pay those high expenses. So if you want to download Rise, if you're an Apple Watch user, feel free. And thank you very much for listening.
Any questions about the meeting?
Usually, so you can tell it when you start a workout, or does it?
No, it'll track just on your Apple Watch. So it's pretty much just kind of like a resting app. You open it and it will track the workouts just based on your Apple Watch. So you usually just have to track it on your Apple Watch. Yeah.
Can it work with some other apps, like hardware from Fitbit or Garmin?
Right now, no, it's just, well, it's all based on the HealthKit API. So if your HealthKit API is actually hooked up, or HealthKit is hooked up to like heart rate strainer, things like that, it will work. So you don't just need an Apple Watch, but you do need Apple's HealthKit. So it will, yeah.
How do you manage all those data once you collect it from the user, like your sleeping history or heart rate history?
So it's all saved into that SQLite database, and I'm just saving the very, again, it would be a lot of data to save, and I don't want to crash anyone's phone. So I'm just saving the very top metrics, like just the recovery percentage, just the workout intensities, just those single numbers. But I do update them as the user's updating them throughout the day. But a user can't go in 3 days previous and change their recovery. Keeps people accountable. Yeah.
Is it a discount Android?
So I just don't have an Android device, so I wasn't able to test that. But I actually would love to be able to work with an Android device and use that. Right now the Apple is very separate from Android, so it's hard to, I think it'd be making this whole nother project again for Android.
Alright.
Yeah, Arise, exactly. Next year. So thank you.
Any other questions, last questions?
Great job.
Thank you.
That concludes our senior presentations. Thank you so much for attending. you guys should stay here for a while. Professor Sita has some announcement.
The other room and we're gonna discuss the. So we're gonna put the stuff out here somehow.
Keep busy. And just a heads up, we'll have senior dinner, so please assemble near my office at 4:30 PM sharp, okay? All right, thank you. I'll just end this.